Hi everyone, so in this video on electricity, we're really going to be looking at ammeters and voltmeters. So the first thing is what's an ammeter and what's a voltmeter. So an ammeter is basically something that is measuring your current intensity in your circuit. Which pretty much leads to the question, what does current intensity mean? So when we're talking about current intensity, the formal definition is the following. It's the number of charges that passes a given point in an electrical circuit every second. So we can kind of think of the current intensity as your speed of your electrons. Now, your current intensity, the symbol is I, and the unit is amps. So the unit, because it's amperes, will be represented by an A, and I is your symbol. One thing that everybody mixes up is the symbol and the unit. The unit, amperes, is how you measure your variable, which is your current intensity. So another way to think about it, and this is probably going to be easier for you to understand. Kilometer is a unit of measurement for distance. So if we're talking about the distance between point A and point B being 2 kilometers, 2 kilometers is the unit that you measure your variable distance. So when we're talking about current intensity, the variable current intensity is represented by the symbol I. Ampere, so shorthand for ampere, amp, is the unit represented by the symbol A. So your ammeters measure current intensity. Now your voltmeters are a little bit different. Your voltmeters are going to be measuring potential difference. So the definition for potential difference is the following. It's the amount of energy transferred between 2 points in an electric circuit. So we can kind of consider the potential difference as your energy of your electrons. Now, the key thing that we have to remember is that it's energy transferred, because you can't actually directly measure the amount of energy in something. You can only measure the change in energy in something. And that's not just for electricity, but it's for anything. When you're looking at the change of heat in a scenario, or the change in energy transfers between one object and another, you're looking at energy transfer. You can't actually measure quantitatively the amount of energy that you have in something. You can only measure how much there was changing from one point to another. Now, for potential difference, and this is, I guess, why everyone mixes up current intensity, because the symbol for potential difference is V. So that's our symbol. And the unit is volts, which is, well, its symbol for volts is the V. So I think this is why everyone gets confused. Potential difference is quite simple. Its symbol is V, and the one-letter acronym for volts is V, whereas potential difference, it's a little bit different. The symbol for current intensity is a little bit different, excuse me. The symbol is I, and the unit is A. So now that we've gone over what current intensity means and what potential difference means, now we're going to look at how you actually plug in an ammeter and a voltmeter in a circuit. So the first one that we're going to look at is ammeters, and then we're going to look at voltmeters. So here we have a picture of an ammeter properly plugged into a circuit. Now remember, considering that the definition for current intensity is the number of charges that passes a given point, your ammeter has to be in series. So it has to be on your main path, because it needs to count the electrons which go by, and the only way it can do that is if it's on the main path. So an ammeter, it's always plugged in in series in your circuit. So now we have a voltmeter properly plugged in a circuit. Now remember, when we're looking at potential difference, we're looking at the change in energy from one point to another. So the only way that you can measure the change of energy is if you're in parallel. So when we're talking about in parallel, again, it means the electrons have a choice to go either through one particular path. So here they can go through our lead element, or they can go through our voltmeter. Now, the only way that you can figure out a change in something is if you look at your energy that you have before you go into the element, so energy initial, to your energy final. So again, it's plugged in parallel because you need to measure the change in energy. Now, our next image that we're going to see is going to be an image of a circuit, and we're going to be looking at three things. Number one, what type of circuit is it? Is it a series or parallel circuit? Number two, we're also going to have multiple ammeters and voltmeters, and we're going to try to identify what each machine is measuring specifically in the circuit. Okay, so first thing that we're going to see is that we have our power supply. We have a voltmeter across our power supply. We have two branches. We have an ammeter that you have before you have your branching point. We have an ammeter on your first branch. We have an ammeter on your second branch. On your first branch, we have a 100 ohm lamp. On your second branch, we have two resistors, each of 100 ohms. And also on this branch, we have a voltmeter going across these resistors. So what I'd like you to do is pause the video and try to see what each element is measuring. Okay, so the first thing that we're looking at is our power supply, and because we have our voltmeter across both ends of the power supply, so across the negative terminal and the positive terminal, this would actually give us the total voltage of our entire circuit. Now, as we're going through our circuit, first thing that we need to realize is that this is a parallel circuit. We know it's a parallel circuit because we have a branch point right here. So basically, at this branch point, the electrons can choose to either go through path number 1 or continue to go through path number 2. Now, knowing that this is a parallel circuit is great because we can figure out, well, if one element is broken on any pathway, the circuit is still going to run. So, we've just basically said that this right here is figuring out our total voltage. This ammeter right here is calculating the total current intensity because this ammeter is positioned in such a way that the electrons, no matter if they chose path 1 or path 2, they all need to go back through this ammeter before going to the power supply. Now, the ammeter that is on path 1 is only looking at the current intensity of the electrons that are going through the lamp. And the reason why is because all your electrons travel through the lamp and then they have to travel through this ammeter. And it's only the electrons that chose this path that is going to be going through this ammeter. Now, the voltmeter here is looking only at the current intensity past this resistor, because it's going to be looking at the power that the electrons have before they enter the resistor and after they enter the resistor. This ammeter is actually going to be calculating the current intensity through resistor 1 and resistor 2 because on this particular branch, the electrons have to go through both of the resistors before they go through this ammeter. I hope this helps, and see you next time.